We use two terms every single day, often interchangeably. We say we are going on the internet or we are surfing the web. In our minds, they are the same thing, a singular digital ether that surrounds us. But this is a fundamental misunderstanding. To understand the digital world, we must first separate the container from the content. We are about to embark on a journey through the history of human connectivity. We will trace the wires buried deep under the ocean and the invisible signals bouncing off satellites. We will distinguish the physical machine from the digital dream. This is the story of the Internet versus the World Wide Web. Let us start with the definitions. What is the Internet? It is the physical infrastructure. It is the massive, foundational network of cables, routers, and servers that connects the entire world. It is hardware. It is copper and glass. Now contrast that with the web. The web is the information layer. It is the collection of pages, documents, and media that we access using the Internet. Think of it this way. Imagine a railway system. The Internet is the tracks. It is the steel and wood that allows travel to happen. The web? The web is the train that travels on those tracks to reach a destination. You cannot have the train without the tracks, but the tracks exist whether the train is running or not. The Internet was not born in a startup garage in Silicon Valley. It was born in the shadow of nuclear war. The year was 1957. The Soviet Union launched Sputnik, the first artificial satellite. It was a metal sphere that shocked America and triggered the space race. The United States realized it was vulnerable. If a nuclear attack took out a central communications hub, the entire military command structure could collapse. In response, the U.S. created ARPA, the Advanced Research Projects Agency. Their mission was to maintain technological superiority and ensure communication resilience. They needed a decentralized network vision. The goal was simple but revolutionary. Ensure communication survives a nuclear attack on centralized systems. They needed a network that could route around damage, staying alive even if parts of it were destroyed. To build this unkillable network, scientists had to reinvent how information moved. The old method was called circuit switching. This was how telephones worked, a dedicated line connected two people. It was inefficient and vulnerable. If that line was cut, the connection died. The new innovation was called packet switching. Instead of one long stream, data was broken into small packets. Imagine tearing a letter into 100 pieces, mailing them separately through different cities, and having them reassemble perfectly at the destination. This technology, pioneered by Paul Barron and Donald Davies, revolutionized communication. It meant that if one city was destroyed, the data would simply find another route. In 1969, the theory became reality. This was the birth of ARPANET. It wasn't a global phenomenon yet. It started as just 4 universities connected together: UCLA, Stanford, UC Santa Barbara, and Utah. They formed the first operational packet switching network. The first message ever sent was intended to be the word login. They typed the L, then the O, and then the system crashed. The first message in Internet history was simply low. It is important to remember the reality of this era. This was complex and unglamorous. There were no pictures, no graphics, just ugly command line interfaces and complex code. This revolutionary technology was hidden behind intimidating technical barriers, accessible only to scientists and the military. By the 1970s, a new problem emerged. There were several different networks springing up, but they spoke different languages. They used incompatible protocols and couldn't communicate with each other. The growth potential was limited. Enter Vint Cerf and Bob Kahn. They developed the solution, TCP/IP. This stands for Transmission Control Protocol, Internet Protocol. It acted as a universal translator, creating a standard language that enabled inter-networking between distinct networks. This is where we get the word Internet, an interconnected network. TCP/IP became the foundation of the modern Internet, a rulebook that every computer agrees to follow to this day. A network was built for data, for calculation, for survival. But in 1971, Ray Tomlinson changed it into something else. He invented email, the first killer app. Tomlinson sent the first network email and made a simple, elegant decision. He chose the @ symbol to separate the user from the host computer. It seems obvious now, but at the time, it was a stroke of genius. This transformed the network from a computing tool into a communication platform. The growth was explosive. By 1973, email accounted for 75% of all ARPANET traffic. It proved a vital lesson. The network's true potential wasn't just data transfer, it was human connection. As the 1980s arrived, the network expanded beyond the military. The National Science Foundation Network, or NSF-Net, brought universities online, democratizing access and driving academic collaboration. But there was a usability problem. To reach a computer, you needed its IP address, a complex string of numbers like 192.168.11. It was impractical for humans to remember these. The solution came in 1983 with the Domain Name System, or DNS. DNS acts as the phone book of the Internet. It translates those cold, hard numbers into memorable names like .com, .edu, and .gov. Suddenly, the digital world had addresses that humans could understand. We have reached 1989. The Internet, the tracks, was established, but there was no train, no websites, no links. At CERN in Switzerland, a British scientist named Tim Berners-Lee had a vision. He wanted to organize research information more effectively. He didn't just write a program, he invented a universe. He created HTML, the language of the web, HTTP, the protocol for moving pages, and the URL, the address system. On a next computer at CERN, he built the very first web browser and the first web server. He laid the foundation for the World Wide Web as we know it today. He built the train. Between 1991 and 1993, the web went public. But the most critical moment wasn't technical. It was legal. Berners-Lee made the crucial decision to release the code for free. He gave the World Wide Web to the world. This open source approach sparked unprecedented innovation. And then came Mosaic in 1993. Before Mosaic, the web was boring text. Mosaic was the first browser to display images in line with text. It brought color and life to the screen. It revolutionized the user experience and for the first time made the Internet accessible to non-scientists and the general public. The mid-90s saw the first great corporate battle of the digital age, the browser wars. It was a battle for dominance between the upstart Netscape navigator and the corporate giant Microsoft's Internet Explorer. Microsoft famously bundled IE with its Windows operating system, creating a controversial competitive advantage that would lead to massive antitrust lawsuits. While ruthless, this competition drove rapid innovation. Browsers became faster, more capable, and feature-rich, but it also highlighted the danger of monopolies in this new frontier. By 1995, the secret was out. The Internet was a goldmine. This was the .com boom. Investors rushed to commercialize this new space. Startups added .com to their names and raised millions of dollars in venture capital, despite having no profits and often no business plan. The mentality was get big fast. Tech giants emerged from this chaos. Amazon, eBay, Yahoo, and Google rose to prominence. An investment frenzy created unprecedented wealth and valuations that seemed to defy the laws of gravity. But gravity always wins. From 2000 to 2002, the bubble burst. The Nasdaq lost 78% of its value as investor confidence collapsed. Companies like Pets.com, once the darlings of Wall Street, went bankrupt overnight, losing billions. The party was over. However, the internet didn't die. The survivors, like Amazon and Google, survived by focusing on solid business fundamentals. The forest fire cleared the brush. And these companies built the foundation for the internet economy we rely on today. Out of the ashes of the dot-com crash, the web evolved. We moved from Web 1.0 to Web 2.0. Web 1.0 was a one-way street, read only. You went to a site and consumed information. Web 2.0, starting around 2004, was the social web. It moved from read-only to read-write. Users shifted from passive consumers to active content creators. Blogs, wikis, and social media platforms empowered user-generated content. The rise of Facebook, YouTube, and Twitter transformed online interaction. The internet became a global, two-way conversation rather than a broadcast. In 2007, the landscape shifted again with the mobile revolution. The launch of the iPhone changed the physical location of the internet. It moved from the desk to the pocket, introducing the era of always-on connectivity. This also launched the app ecosystem. Mobile applications began replacing traditional browser dominance. We stopped surfing the web and started opening apps, creating entirely new categories of services and business models that required you to be online 24/7. To support this mobile, media-rich world, the pipes had to get bigger. We witnessed the rise of streaming and broadband. We moved from the screeching sounds of dial-up modems to the silent speed of broadband and fiber connections. This high-speed internet enabled video streaming services like Netflix and YouTube, which were previously impossible. This caused massive industry disruption. Traditional TV and music industries faced existential challenges. Today, bandwidth usage has skyrocketed, with video content making up the vast majority of all internet traffic. Where does all this data live? It lives in the cloud. Cloud computing represented a massive shift in the computing model. We moved from storing files on our own hard drives to storing them on massive server farms owned by Amazon, Google, and Apple. This gave rise to software as a service. We now rent computing power and applications rather than owning hardware. It is scalable, flexible infrastructure available on demand to anyone with an internet connection. The computer is no longer the box on your desk. The computer is the internet itself. Now, the internet has escaped the screen. We have entered the era of the Internet of Things, or IoT. This involves connecting everyday objects like fridges, thermostats, and doorbells to the internet. Devices like Nest thermostats learn our habits and automate our homes. But this convenience comes with a cost. Security concerns are rising. Security risks increase dramatically when you have hackable devices, yes, even toasters, connected to your network. Furthermore, the massive data collection on our daily habits raises profound privacy concerns. As the network grew powerful, it also became a weapon. We must acknowledge the dark side, surveillance and cyber warfare. In 2013, the Edward Snowden leaks exposed massive government surveillance programs. It revealed that the tracks we travel on are being watched, sparking a global debate about privacy versus security. Simultaneously, cyber warfare emerged. Cyber attacks on critical infrastructure like power grids and banks have become common. Hacking is no longer just for criminals. It is a tool of statecraft used by nations to wage war without firing a shot. Finally, we must understand the scale of what we are looking at. The web we see is only a fraction of what exists. The surface web, the sites you find via Google, makes up only about 4% of the web. Below that is the deep web. This is the majority of the internet. It contains password-protected content like bank accounts, medical records, and subscription services. It isn't secret, it's just private. And at the very bottom lies the dark web. These are encrypted, anonymous networks accessed via tools like the Tor browser. While often a hub for illegal activity, it also serves as a sanctuary for activists and journalists in oppressive regimes. From a fragile military experiment to a multi-layered digital universe, the internet and the web have become the central nervous system of humanity. Thank you for watching.